difficult. If you prepare, it is easy. Yes? Okay. Listen, we can start our next lesson. Work and energy. Okay, work and energy. See, in our everyday life, we are doing more works. Which are the works we will do? Running, walking, reading books, and pushing the table, pulling the table, throwing ball. Yes, we have doing more works. Yes, in our according to our physics subject, we have work done by when a force applied on an object, it moves through a distance in the direction of the force. For example, when we are pulling the table here, okay, listen, from here we have to push the table from here to there. So the table is here or chair, okay, this is the chair. When we push the table from here, the table moves from here to this place, okay. So work is done there. How? When we are applying the force, the object will be moved from one place to another place. It has distance. The object moves distance in the direction of the force. That means we are applying the force from this way to that way. So, according to their direction of the force, the object will be moved. Do you know the effects of force? Effects can change their direction of the object. Force can change their size. Force can change their shape. Yes, these are the effects of force. So, when we apply the force on an object, the object will be moved some distance in the direction of the force. And another one example, when we pull the chair from here to here, the direction of the force is from right to left. So, the object moves from here to here. Okay. So that we know work is done. Without moving the object or without changing their shape or without changing their size, work is not said to be done. Okay. Listen here. This is the board. Okay. When we apply the force on the board will not move there because it was fixed in the wall. So it's not moving. So work is done there, but we will not say work is done. We will get tired when giving the force, but the board will not move or board will not change their direction. So according to our physics, work is not said to be done. Okay. Sometimes if we are carrying heavy loads, we will be stay here 5 or 10 minutes. Because of carrying the heavy loads, we will be get tired, but work is not said to be done according to our physics, because only we are standing this much time, okay, 5 minutes or 10 minutes, but the object will not move from one place to another place. It will be not distance, okay, not changing their direction, okay. And shall we say some example? Do you know some examples what should to be done? See, walking, that means we are moving from one place to another place. So when we apply the force through our leg, work is said to be done because we are changing our position. Yes, so that is called work. And climbing the steps and stretching the rubber band. See, stretching the rubber band, it is pulling. Okay, when we pull or push an object, it is called force. Yes. So, stretching the rubber band, it is the example of work is said to be done. Okay, we have more examples. When we apply the force on an object, the object moves through a distance in the direction of the force. When we apply the force from here to there, the object will be moved from this place to that place. When we apply the force from there to here, the object will be moved from there to here. So that is according to the direction of the force. Okay, this is the work. Now, how to measure the work? When we determine the work or measurement of work, we have two factors. One is the force applied. When the force will be applied, the work should be done. And another one is the distance through which the object moves in the direction of force. Okay, so we need force and distance. So what is the letter of our work? Work considered as W and force considered as F and distance considered as S. Okay? Work considered W, force considered F, distance considered S. When we use these three letters, we have to make formula to find the work. In which formula we have to use? Work is equal to force multiplied distance. Distance in the direction of the force. Okay. So work is equal to, when we have to find the work, we have to use this formula. Work is equal to force into distance. Listen, it has SI unit. Okay. SI unit of work depends on the SI unit of force and distance. Okay. What is the SI unit of force? It is Newton. Then what is the SI unit of distance? Meter. Okay. So 1 Newton. Listen here. Newton into meter. Okay, so what is the SI unit of work? Newton meter. When we have to consider Newton meter, we have to also say joule. Okay, so 1 joule is equal to 1 Newton into 1 meter is equal to 1 Newton meter. So 1 joule is equal to 1 Newton meter. We have to write Newton meter or joule. When we find the work, we can write the answer Newton meter or joule. 1 Newton meter is equal to 1 joule. So Newton meter is equal to joule. Okay? Shall we do some problems now? Listen the first question. Find the work done if a force of 1000 Newton is applied on a load and the load moves through a distance of 50 centimeter. Okay. Force is given and distance is given. Okay. We have to find the work done. Okay. Force is equal to 1000 Newton. Then distance is equal to 50 centimeter. Listen, when we have to use this formula, force into distance, Newton meter. So we have to change the centimeter into meter. Okay. So what we have to do here? What is the formula? 1 centimeter is equal to 1 by 100 meter. This is the formula. We know. Yes. So we have to change this. 50 centimeter equal to 50 divided by 100 meter. We have to write 50 divided by 100 meter. Which answer will be get? 0.5. Okay, 0.5 meter. So now we have to change centimeter into meter. Now we have to substitute the value. What is the value? What is the formula for this work done? Work is equal to force into distance. Force. What is the force? 1000 Newton into distance 0.5 meter. Okay. We have to multiply these numbers. 1000 0.5. 0 0 0 1 5 is 5. Okay. After we have no number, one decimal is here. Okay. After one digit we have decimal. So we have to keep the decimal here. What is the answer now? 500 Newton meter. Yes. What is the unit of work? Newton meter or joule. Then we can change into joule. 500 joule. This is also correct answer. Okay. What we have to do now? Force is given 1000 Newton. Distance is given 50 centimeter. This 50 centimeter we have to change into meter. 50 by 100 meter. So 0.5 meter. Next we have to substitute these values in this formula. W is equal to force into distance. Force 1000 Newton into 0.5 meter. We have to multiply this. So 500 Newton meter. Newton meter is equal to joule. It is equal to joule. Yes. We have to write in Newton meter or joule. So 500 Newton meter. This is also correct. Then we can write 500 joule. Next question. If the work done is pushing a trolley by applying a force of 850 Newton is 1275 joule. Calculate the distance moved by the trolley. Solution. What we have to write now? Force is given. Okay, so force is equal to 850 Newton. Now, answer is in joule. Yes. So, work done. Work done or work. Okay. Is equal to 1275 joule. What we have to find? Calculate the distance moved by the trolley. We have to calculate distance. What is the formula to find work done? Work done is equal to force into distance. Yes. So we have to find the distance now. Distance is equal to work divided by force. Okay. Now we have to substitute this value. Work done 1275 divided by force 850. Okay. We have to divide these numbers. What we have to do now? We have to use fifth table. Okay. Listen. 1 5 is 5. 3 balance 35. 7 5s are 35. 0. Here 2 5s are 10. 2 balance 27. 5 5s are 25. 2 balance 25. 5 5s are 25. Again we have to use fifth table. 3 5s are 15. 2 balance 20. 4 5s are 20. Here 5 5s are 25. 1 balance. 1 5 is 5. Now 51 divided by 34. Okay. We have to divide this number. 51 34. 134 is 34. Subtract this value. Here 11. 11 minus 4 7. Here 4. Okay. 4 minus 3 1. Balance 17. So we have to add one 0 here. We have to keep decimal. Okay. So 170 is there. Here 5 34s are 170. Listen. 4 5s are 20. 2 balance. 3 5s are 15. 16 70. Okay. What is the answer now? 1.5 meter. Distance we have to write in meter. Yes. equal to W by force. W divided by force. We have to substitute these values, divide these numbers, and we will get the answer 1.5 meter. Listen the next question. Rahul pushed a toy car and it moved a distance of 5 meter. If the work done by Rahul is 1500 joule, how much force did he apply through the push? Okay, first solution. What are the things given here? Distance is given and work is given. So, we have to write the distance first. Distance is equal to 5 meter. Work is equal to 1500 joule. What is the formula to find the force? Here we have to find the force. So, first we have to use the formula work is equal to force into distance. From here we have to find force. So, F is equal to work divided by distance. Here we have to substitute the values. Work is equal to 1500 divided by distance 5. 1 5 is 5, 3 5s are 15 and 0 0. What is the answer here? 300 Newton. Okay. What is the unit of force? Newton. So, we have to write Newton. 300 Newton. This is the simple formula. Okay. Simple question. Very easy question. Next question. These are the two problems homework. Okay. This is very easy question. Now we have did some problems now. Same questions. Find out the work done when a force of 30 Newton displaces a body through 8 meter in the direction of the applied force. What we have to find? We have to find work done. Okay, force is given 30 Newton and distance is 8 meter. Okay, what is the formula to find the work done? W is equal to force into distance. So, we have to multiply these two numbers. It is easy. Yes. Next question. 3000 joule work is done by a machine by applying a force of 500 Newton. Calculate the distance to which it is moved. Work done is given and force is given. We have to find the distance. This is easy. Okay. You should do this homework and have to practice well using the formulas. After doing this homework problem, take photo and send to me the WhatsApp. Okay? Okay children, you should refer the book which we learned today. Okay? Children, we can do the exercise now. From your science book, page number 57. Page number 57. Write T for true and F for false. Correct the false statements. First question. In physics, reading a book and pushing a wall are considered to be work. What is the answer? Answer is false. Why the answer is false? The correct answer is in physics, reading a book and pushing a wall are not considered to be work. Because it's not moving, reading book and pushing a wall. Second question, when a force is applied on an object and if the body moves in the direction of applied force, work is said to be done. Answer is true. Third one, work done is equal to force divided by distance. Answer is false. What is the correct formula? Work done is equal to force into distance. Fourth question. Newton meter is also called joules. Answer is correct. Fifth one. 1 joule of work is said to be done when a force of 100 Newton acting on an object moves it by 1 meter in the direction of force. Answer is false. Because 1 joule of work is said to be done when a force of 1 Newton acting on an object moves 8 by 1 meter in the direction of force. Okay, instead of 100 Newton should become 1 Newton. So answer is false. Thank you.